project
So,
is called Magnets versus Temperature.
Magnets
And
versus
my
temperature.
question is
And
a
my
magnet
question
stronger
is,
when it is
is a
hot or
magnet
cold?
stronger
And my
when it is hot or
hypothesis
cold?
was if the magnet is cold, then it will be stronger because the atoms aren't moving as fast. So my materials are a freezer, a lighter or a lit candle, a stopwatch, a metal paper clip, a ruler or measuring tape, either one, you'll be needing the inches, tweezers, and a rectangular magnet, preferably 1.2 centimeters by 2.5 centimeters. My variables are, my independent variable is the temperature of the magnet, my dependent variable is the time it takes for the paper clip to reach the magnet, and my controlled is the distance between the magnet and the paper clip, and lastly my constant is type and the shape of the magnet. So first, to start off, so step number 1, you take the magnet and you place it in the freezer so it becomes really cold. Like, magnets get cold really easily. And then step 2, place the magnet at the end of the ruler or measuring tape, and place the paper clip to reach the magnet after each of the 5 trials. So you'll repeat a series of 5 trials, and then so after each of the 5 trials you will mark your data, and in order how I told if the magnet was strong or not, it was between the time when the paperclip would reach the magnet. So the faster the stronger, because if it moves the fastest, that means it's stronger, and it's so strong that it's pulling it really fast. Step 3, with the tweezers, pick up the magnet and hold it over the flame from the candle or lighter until the magnet is very hot. Put it down on the measuring tape in order to measure it. Step 4 is repeat the same exact process as step number 2. My results were, so trial number 1 was, for the hot, was in 0.32 seconds, and the cold was 0.29. The second trial was 0.35 for the hot and 0.19 for the cold. Overall, 0.19 for the cold was the fastest, which means the cold was the strongest. The trial number 3 was 0.43, and the trial for the cold, trial number 3, was 0.42, so just one off. Trial number 4, the paperclip did not move. Trial 5, once again, the paperclip did not move, it just stayed there. And for the cold, it was 0.32 seconds. Overall, cold had the least amount of time, so cold was stronger. And in my graph here, I could not graph trial 4 and 5 because the magnet failed to work, so it just stayed there. My conclusion is, when a magnet is heated up, all of the atoms jump around, which makes it hard for the metal or whatever can attract to a magnet to actually attract to it. So when a magnet gets cold, the magnetism grows stronger, because when it cools down, it's obviously the opposite. So when it cools down, the magnetism is stronger and it pulls it faster. And my hypothesis was correct. I predicted that the cold magnet would come faster, or the cold magnet would be stronger than the hot magnet. And After 5 trials, for the last 2 trials for the hot magnet, I believe that the magnet has lost its power. So the paperclip will adhere, just not when the magnet reaches a certain heat or like a certain temperature. And if I had redone the experiment, I would probably measure how hot I got the magnet so I can make them all the same. And maybe if I made them all, the same, then maybe the project would be different. Maybe my results would have turned out differently. And I would try out maybe different types of magnets, see if that also affects. And I would probably also change the distance away from it. I would probably move it 1/2 inch closer because it was at the 1.5 inch mark. And just be careful when handling hot stuff. And magnets are part of our everyday lives. Like phone cases have them, iPad cases have them. Like just to close your iPad in general. You may not know this, but your MacBook actually has one. Or your iMac. Your iMacs actually have magnets at the top for your headphones, so you won't lose your headphones. You just stick it on, and it's a magnet. There's also magnets in purses to close them. There's magnets sometimes in school supplies to also close, or to hang stuff on the board, or to just have decorations on your fridge.